Okay. Hey everybody, Random Gene here. So, today's random video, I think I'm gonna go over SDR. We'll set it up, show it a little bit, see what it's all about. But here in New York, definitely have some cold, blustery weather. Some snow, horrible. It's very cold. There's Abby the cat. Hey Abby. Alright, so let's go ahead. Let's go look at what SDR is. So what SDR stands for is Software Defined Radio. Ultimately is you get what's called a dongle, which plugs into the USB port of the computer, an antenna base, and two antennas. When you connect it to your computer, you can receive radio broadcasts or transmissions with the right software. Hence the name Software Defined Radio. So you can listen to broadcast radio stations, as I said, or police frequencies, fire department frequencies, amateur radio, CB radio. You know, it's a very wide spectrum, and it covers pretty much almost all of the radio spectrum. Including the airband, planes and actually military aircraft, and this all depended with the right antenna. So what they do is they give you, when you buy the kit, which is about $20, you get two different size antennas. So how did it come to be SDR radio for a computer for $20? So years ago they came out with these little dongles that you would plug into the USB port of your computer, connect an antenna to the dongle, and you could receive television. With the software supplied with this, you could watch TV on your computer, not internet-based TV, but RF TV or broadcast television, local to you. So what happened was some crafty people along the way realized that with the right software and possibly some hacking or modification of the dongle, you could receive the entire radio spectrum and listen to it and tap in and actually see a display of the radio spectrum, see where there's frequencies, and then tune into it. I'm going to show you all that. So this is the RTL-SDR.com website, and you would click over here for the quick start guide. And what happens is the quick start guide, it gives you an entire how-to of setting it up and getting the software installed and working. That's what we're going to do. I'll download it, I'll get it going, and we'll go from there. So here's where we're at. Let me go back here. I have loaded the software and the drivers. The dongle is set up, connected to the laptop. I have the small antenna connected to the dongle. And let's go ahead and start the software. Again, I was just following the directions on that RTL website. So now, with this, it's easy enough to figure out. So let's press play and see what happens. First of all, cannot open AirSpy device. Okay, that is because right here it says AirSpy. We need to pick the dongle that we have from the drop down, and that would be RTL SDR USB. Click that. We'll press play, and we're starting to pick up noise. Okay, I dropped the volume down over here. So let's just go over what's here quick. This here is called the FFT display. It's basically the signal display. You have signal strength on that axis and frequency on that axis. On the bottom is basically a waterfall display, and it shows the signal over time. Let's go ahead and make some settings here. So the first setting we're going to do is the noise. So all this blue, this is all noise that we hear. So we're going to drop that down, and that's going to be with the range. Over here is the range. Zoom is top, so range is right here. We are going to adjust this. You'll see that noise floor drop down. See? I think that's about good. So now we got that. That changes the entire waterfall display. We have a lot less noise being shown, and it's easier to pick out signal. So the next thing we'll do is the gain. We'll try to draw out some more of that signal, and that's going to be over here in the configure button, I'm sure. Yeah, so the RF gain is set at the minimum, so we're going to bring that up. You want to be careful when you adjust your gain, because you'll bring in too much noise if you do. So when you adjust the gain, you watch your signal, and try to bring it up. So there we are. You can see the signal's really starting to pop out. See what happens when we bring it up too high? It starts mixing. Signals start mixing. You're creating noise. Now you're just creating a lot of noise. So you have to find that sweet spot. And I'm already hearing signals coming through. So we can keep it there, and maybe a little bit lower. And we'll go with that. We'll keep it there. And this is interesting. Frequency correction, PPM. On the dongles, or pretty much any type of transmitting device or receiving device that's based off of frequencies, in the electronic circuitry needs a baseline of a frequency so it can adjust to a frequency that you want or you want it to listen to, etc. So it usually has a crystal or some sort of device in it that oscillates at a known frequency. And whatever these are designed with, I'm not sure, but you can adjust it for inaccuracy. So what you would do is you would take a known signal. Usually sometimes they'll call it a pilot tone or a beacon, but we'll do it with one of these FM broadcast stations. This looks like a nice signal, strong enough. If we click it, we got 105.1. That's a local radio station. So we know it's 105.1, and it is a FM broadcast. Now, FM broadcast stations are held by the FCC to have to keep very tight tolerances. So you know that frequency should be 105.1, and we're going to adjust for frequency correction if it's needed. So let's close this configure for a moment, and let's zoom in. Let's zoom in on the signal, and we can really see how far off. So are we? Actually, we may not need to adjust anything. I'd probably find a better signal. Let's actually see about finding a better signal. Okay, so this is 105.9, another local radio station, and I gotta tell you, we don't need to adjust the oscillator because it's quite good. So what would happen is if we would tune to 105.9 over here, and the peaks of this signal was to the left or to the right of that red line, then for sure you could correct that. You would want the red line right in the center of the signal, much like it is now. So if it's not, you can adjust it through the software. So this way, when you tune to 105.9, it's definitely on the signal 105.9. So I'm going to bring the zoom back out, okay, and show something else interesting with this software, and then we'll listen to some stations. So I'm going to pick up here. This is 105.1, and it is also, the software is given the RDS data. So, for instance, if you're in your car and you listen to FM radio, and your radio gives the RDS data, such as what station and what song is on. So let's turn up the volume, and we'll scroll around. So, not really my type of music, but you can see how you have the signal with the strength, the waterfall display over time. Very cool. This signal right here is a classical 105.9. And then I'm going to click and just drag and swipe. And like I said, this is the FM broadcast. We're only showing between 104.7 and 106.2. So if we come up a little higher, there we are, we're changing everything. It's still that classical. This is 106.7 with Whitney Houston. She wants to feel the heat. Huh. Alright, anyway. So yeah, I mean, what's great about this now is when you're using this for things like shortwave radio, ham radio, and you want to find transmission, you can see a whole wide spectrum of it, and then click. This is still FM broadcast, 106.7 again. This is 107.1. Okay. So, if we just keep scrolling through, now we're coming into the airband. This is the VOR and ILS. This is all for navigation. But we'll see if we get into airband voice. Keep dragging. Airband is actually quite a big band. Okay, airband voice. We'll see what's coming in. So you got some very narrow signals here. I haven't clicked them yet, but there's two. But I do want to show one thing. This over here, narrow FM, wide FM. And so this software apparently automatically adjusts your the type of signal you're at. So wide FM is your typical broadcast FM. Narrow FM would be like ham radio, VHF, UHF stuff. Dual sideband, CW, which is Morse code, AM, lower sideband, upper sideband for HF, amateur radio and whatnot. So again, this is airband voice. Let's see if we can pick up any airlines. So I don't know if you ever listen to the airband. Pilots talk very fast. There you go. Turn down the squelch. Oh, what did I do? I hit something. Let's see what I did. So here's what I did on this. On FFT display, where you can view both. Somehow I knocked that to just a waterfall, and that gives you just that. Or you can do just the spectrum analyzer, or both. Okay, let's see if we can find some more transmissions here. I have this squelch. I hope this squelch is not too low. We're gonna do this a little different. I'm gonna turn the squelch on. That'll drop down the noise, and only when signals come out. So, like for instance, the signal keeps popping up here. We could monitor that for a moment to see what pops up. Nothing. It's not even breaking the squelch. So up here, the local tower at the airport, I believe, is 126,800 megahertz. So 126. Then we're just going to keep clicking it to bring it to 8. Bring that to 0. And make the next one 43210. 126,800. That tuned the line here. We're tuned over here. Yep, 126,800.
Right, report to head for Endeavour 3404.
There's the local air tower.
Oh, thanks so much.
You're welcome. Anyway, yeah, so that's that. So you can find frequencies, but there's things that'll pop up. You can monitor the ones that'll keep popping up. There's another one popping up there. Let's see what this one is. That looks a little active.
Okay, 17,000 direct
Now remember, we're working off of an indoor antenna here. If you have ham radio antennas or any type of antennas on the roof, that'll work much better. So I'm not down in the ham shack right now. I'm up here in the office because I wanted to use the regular antennas that came with the system, and just so you notice, I did change it to the large antenna. Okay. You know, I'll set this up in the shack, and I'll probably connect it to some of the outside antennas. But yeah, so that's that. Let's see what else we can tune to. Okay, so as you can see, we're in the 2-meter ham radio band, or the VHF band. So that we'll scroll through and we'll see if there's any signals. It's probably the worst antenna system for any of this. Okay, so we're not picking too much up in the 2-meter ham band, most likely because not too many people transmitting on 2-meter right now, or the antenna isn't all that great. Just a couple of repeaters IDing. Yeah, the 2-meter ham bands are a little quiet. Let's try. I'm gonna some public utilities. Let's go up to like 1.5. I don't know, 2. What do we got? So 152 megahertz. Got some signals popping up here and there. Hackensack.
Vehicle 1, Charlie Zebra Victor 1594 is coming back valid to a 2014 Nissan Pathfinder, color white, to a party out of Nyack. Vehicle 2, Henry X-Ray Yankee 1113 is coming back valid to a 2018 Ford Explorer, color white, to a party out of Terrytown.
10-4, vehicle 1, is that registered to a Carmen Bowen 81469?
10-4.
That could be owner op at this time. EMS is checking out vehicle 2. I'll get back to you with that.
Okay. Interesting. So, SDR radio, pretty much kind of endless on what you could do, and this is just a small portion of it. You still have HF, short-wave radio broadcasts to listen to. I mean, I could sit here all night and play around, but I would definitely, for myself, because I have it, connect it to some better antenna systems. But what I like is you can see the signals, so you may not know where to tune, but you can see them, and then you can tune in and listen in. It's a great way to search out frequencies. That's what I like about this. Okay, so there you have it. SDR, software defined radio. Pretty good. Truth be told, I purchased this about 3 years ago, maybe more longer, and I kind of just sat down in the shack for a long while, and I never touched it, and I just recently got a renewed interest in it. I started playing around with it. Yeah, it'll come in handy. Pass some time, play around, search out some frequencies down in the shack, whatnot. But yeah, so it works out pretty good. And that's about it. What else do I got coming up? I got a couple of videos planned. Got a hiking kit I'm building, or putting together, I should say. Some things to use in an emergency while hiking. I got a 72-hour kit that I'm putting together for my truck. Another cool one, I'm building I'm going to be putting together an APRS, automatic packet reporting system, ham radio APRS tracking system. I'll have that hooked up. So I got a few videos, some content planned. We'll see how it goes as time permits. Anyway, so SDR, it's real easy to get going. Instructions are there. This software, I should point out, it's called SDR with a pound sign, or these days, what do they call it, a hashtag? Anyway, that's SDR Play. That's the name of the software that's used. And it seems to be a go-to. You can do a lot of stuff with this. It's you can even download the raw data and download weather images directly from satellites. There's a lot of content on YouTube and websites that direct you how to do it. So it's for $20 you can't go wrong. You know, it's a pretty cool piece of equipment. So that's it. Thanks for watching, and catch you later.